Okay, so thank you, Benjamin, and thank you, Mike, for this invitation. It's a great pleasure to be here today in this location. I had to travel far a lot to come here from Italy. It was 24 hours of travel, but nevertheless, it's really worth to be here, and that's why I'm thankful for this. So, who am I? I'm Vito De Gaetano, working for Bosch since almost 20 years. And I spent most of my time working in different locations, in different plants, and working for SAP projects, especially for plant maintenance related projects. And since 5 years, I am also coming into the taste of IoT. When I discovered the first time how IoT, because I'm more or less coming from the process engineering, and then coming into the IoT world for me was like mind-blowing, seeing what's possible with the power of IoT to do and move things on. So since 5 years, I'm addicted to IoT, especially to connected industry. That means the industrial IoT version that we have. And last year I moved to the central department, one of the central departments of Bosch, and so-called accelerator. This is why you see here the words accelerator. It's our name because we're trying to move fast, accelerating the digital transformation of our plants inside our manufacturing plants. And yeah, my office is located close to Milan, and yes. So the first question when maybe somebody who asked me, so how does open source and industrial IoT fit together? Because when you think about open source and industry, normally industry is related more or less to business, but as Mike explained, using the power of open source is attracting new ideas and new business opportunities. And this is why we are also we are really pushing forward to this even internally in Bosch. For example, we have an open source community. It's a Bosch internal open source community where we share ideas in between all of the 280 plants that we have, because like in a Darwinian way, the best ideas survive and they will be improved. At least this is a little bit the philosophy of sharing the best things with others. So under the hood in a manufacturing plant, how can we abstract the best things of a manufacturing plant? How can we and understand why the IoT is so relevant for the industry? So regardless of the type of production that you have, of what you're producing, basically there are a lot of topics that come quite close and quite similar to the IoT. We are talking about data coming from machines which are getting more and more smart and also verbose, because they're producing a lot of data coming from sensors, coming from controls, and we are almost overwhelmed with this data. What we found out that many plants, they have tons of data, but what to do with this data, how to handle it, how to treat them. It was just a rough estimation that only maybe 1% of the data are really used, not useful, used. So how to come out of this situation? Basically, also thinking about that we have different data formats, we have different environments, physical environments, we have different hardwares, users, locations, and so on. So there is a huge variety of situation that you can fetch in each and every production plant, regardless of where you are, in which part of the world, what product you are doing. And the question now comes to this, how to manage this complexity, and is open source something feasible for this situation? So when I was trying also to explain to my kids, for example, they're all now old enough to explain this, but when I explain them what exactly is industrial IoT, I show them this map. Maybe you will not immediately recognize. So if we don't have any Japanese attendee here in the room, this is the full Tokyo metro system. So for the transportation system of Tokyo, one of the biggest and more excited cities I visited in the world, but it's really huge. So if you think about people from different nations, different languages, cultures, ages, and so on, and materials, everything is flowing in a really perfect way. And you are getting from one point to the other point, and it's really amazing how this is working. And of course, this is also significant because you can commute. You can reach your target, you can reach your destination, even not owning an own metropolitan line. You can share the line. You can share, of course, you pay for the services that it's giving to you, and it's a huge opportunity for each are contributing to this. This was a little bit the connection to the explanation why or how this industrial IoT can be applied. Because in the industry, it's like this. Yeah, it's confusing if you don't know exactly the details. So the question is it applicable? Is an open source technology applicable for an industry? Well, a couple of months ago, I had a great pleasure to meet Dave, Jonathan from Cloudera, and also from Red Hat, some colleagues in Eurotech, and they showed me some slides where they say, okay, we have an open source stack made with building blocks coming from the open source technology of the IoT, Eclipse IoT community, and they explained me how this is everything working together. And I say, okay, you know what, let's try to make this proof of concept to see, does it fit to a real environmental, industrial environment where we have also the constraint of info security, because security is a big topic. Clearly, we had some examples some months ago. What can happen in an industrial world if you're not secure enough? So we have to bring in technology that is working and that is secure. And we wanted to prove that, by the way, also, if it's possible to use also existing, this stack, not on top or disrupting what you have already in your environment, but integrating with the all-running system. Yeah? So in an enterprise IT that is already there, you just plug in and play. And since this was maybe not challenging enough, we said, you know, let's squeeze it and let's stretch it to some other objectives. We wanted to integrate, for example, some other Bosch contributions in the Eclipse IoT community. So we had, for example, we wanted to add the Eclipse Ditto, which is used for the digital twins, since we're using a lot of digital twins, I will explain, and the Eclipse Unide for a multi-end communication protocol between the plants and between different companies. And last but not least, also applying the deep learning for Java, deep learning for J, as a bundle on the edge, and to see if a trained model in the cloud can be deployed and executed on the edge. Challenging because we did this really short time. We discussed the first time in December, where you realized it in 1 week in Italy, in this Italian plant. So concrete, or to speed up, we said, okay, how can we start? Where do we start? So we took a Bosch sensor XDK, which is a programmable sensor and the prototyping platform for any IoT use case, because it has embedded IoT real-time operating system. It's you can write programs also in C and so on, and I'm not a programmer, okay? So for me, writing a program in C was really scary. I will show you that thanks to one of the Eclipse projects that is there available, it was quite easy to write it, okay? So 8 sensors, yeah, you can say accelerometer, magnetometer, and so on, everything that you want to sense in an environment. How to transmit these data then from the sensor, from the device, to the running applications. We are talking, for example, of Tableau, but we have also our commercial, our Bosch IoT Cloud, where Ditto is running under different names, but the same application, or the Production Performance Manager, and so on. Our own M4.0 stands for the internal Bosch community of open source developers, so sharing the ideas. So how does it fit? Because if I have to write for each application one specific protocol and communication, it would be really a mess. And we definitely would not succeed in 1 week. So this seems quite a standard template, yeah, of how to integrate devices into for example, into a data lake. Consider the red bar and the green bar below. The red bar means you are in a secure zone. It says secured and encapsulated network, yeah, where you have, for example, your machines from different suppliers, and you cannot handle the technology on that from the corporate IT department. So we place this IoT gateway. This IoT gateway is collecting, both of them are in this red zone, collecting the telemetry data over, we decided to use the Wi-Fi connection and transmitting with the protocol, also here MQTT, transmitted to an integration hub where some further services are stored and used. And also the communication between the gateway and integration hub, this is also really interesting, is running only over one port. So you don't have to open up your firewall to too many applications or too many connections. You are using only one port, and this increases the security because you are exactly knowing which gateway is communicating with which integration hub. So this makes it a lot more secure than different solutions. And at the end, from the integration hub, you have the chance to push these data to a data lake, or for example, in our case, in parallel also, based on the routing that happens on the integration hub to the digital twin, and from there on, you have the application level, the application layer. So what's the benefit here? Basically, you are decoupling the complexity of the front-end developer, who maybe are aware programming in high-end languages, from the complexity to handle the device languages, or even the device complexity, how to communicate. If you think a high-end developer has to think about C, how to connect, what is the protocol, and so on. And this does not, or it's really difficult to make it work only in one hand. It's not a one-man show. So we started here in this case using open source technology from Eclipse, like PAHO for the communication protocol. We used it as a library inside the Bosch XDK, and the Meta and Eclipse Vato for defining the model and transpiling the application level. You will see a slide coming next here. On the gateway, as mentioned by Mike, we were using the Cura, which is it's a gateway framework running on OSGI, and it's Java-based, and where you can have the device management, and you can in parallel run the deep learning 4J also here in order to have the execution stuff directly on the gateway. It was interesting, for example, because one of the stretching objectives is exactly grab data from a production area, transmit it, even in a batch mode, because you can schedule this, to the data lake or to the data management system, analytics system, train your model in remote, and then bring back the complex models back to the gateway. So you don't have to have a powerful gateway hardware in order to run the execution of your model. You just need a working environment where you train the data, okay? And this is really, this opens a lot of more opportunities. Going on the integration hub, we choose, for example, the OpenShift origin, because this was the support by Red Hat. The advantage is with OpenShift, you can containerize your applications. So even if you are not familiar with all and each programs, program languages, it's quite easy to implement it with Kubernetes and with other container tools. And here you still see on the slides, because currently it's running on ActiveMQ as a messaging system, but there are a lot of efforts now also to bring here another Bosch contribution, which is the Eclipse Hono, which is not only a messaging system, but you can find also on the internet site of Eclipse IoT the information about Eclipse Hono, which is messaging and transforming of payload. So you don't have to be aware about which are the protocols there. Of course, bringing then the telemetry data to the data lake, we're using the ingestion with Kafka, and using Spark to push then on the Hadoop cluster and to Kudu, which is really new technology of Cloudera, and I really appreciated how to use it, because with Impala you can directly access the storages like with a SQL language. So even if it's really powerful as Hadoop cluster, as the HDFS, but it's more you have availability of structured data. Ditto, as a digital twin. Again, here we are storing the information about the digital representation of the physical devices. Why storing these devices, or why storing the digital twins? Because at the end, if you are, again, a programmer, you want to interact, you don't have maybe all the time 24 hours connection, in this case, back to your device. You still have the last output, and you have directly all the representation which is necessary and relevant to understand how the system is working, or how your all devices, where are located, how to communicate. That doesn't matter to you if you just want to know how is the status about my device, and how can I, for example, simulate also the interaction. So instead of having directly accessing to it. And then in the end, you know, as I mentioned, all the enterprise, consolidated enterprise IT. Eclipse Meta, or Mita, still I don't know how to pronounce it. I would say, as an Italian, I would say Meta. It's a tool by which it's really easy to program IoT devices. Yeah. At the end, you see on the right side an example where you have a high-level language description. It does not look like C, but the advantage is that you can define your connectivity, you can define your devices and so on. You can also define the function blocks, how these are going to fit together. And in the end, you transpile it. You don't compile, you transpile it to C. And in C, once you have it in C, if you are aware and familiar with C programming, you can do your fine-tuning of the connection in the program. So for me, this was really saving time, a lot of time. And Eclipse Water, for the sake of time, maybe I have to see Benjamin at the time. It's okay. Okay, that's great. Didn't see it, thank you. Eclipse Water. Eclipse Water, maybe you have seen it already also in some other sessions. It's also a project that were contributed by Bosch, and you have the chance to abstract the description of your device. Why do you do this? Because if you're a device producer, you have to hand over to your end users the model of how the data are transmitted. Coming back to the example of the XDK. If you know, for example, okay, I have the accelerometer, magnetometer, temperature, humidity, and so on, but I don't know the format. I don't know what is the notation. And for example, should I send which type of data and so on. So you should hand over to your end customer or to the developer also a certain model. And the fact is that you can generate the model, bring it into a model repository, and give the opportunity to the end users to share these models and to make a transcription based on the platform that you're using, how this is working. So for example, here you can see the device manufacturing is using the toolset of Water, describing the device that he has generated, and creates an information model as a template. The template is stored in the information repository, and the platform vendor we are using, for example, the Bosch IoT Cloud, you can access to the information repository, pick the model that you have described, and by this you can generate, the solution developer can generate, thanks to this input, pieces, scripts, or parts that you are using then in your development application. For example, written then in Java, C++, Python, and so on. And here, for example, also in this case, it's possible to have, for example, you have to write an OSGI bundle for Cura, where you're going to install your the connector, the device connector, from the gateway to the device. You can use the platform using this template or this model, compile it, or let me say, generate, because it's a code generator, OSGI template for Cura, and use this and bring the bundle into the Cura, deploy it. I mentioned Eclipse, Ecura, and Kapua. I mean, almost since plenty of sessions I have seen also online, we're describing. I don't want to go too much into the details of this, but it was the interesting part where we said we get the images downloaded as a plug and play. So it was quite easy to get it running. In this case, for the proof of concept, we use, for example, a Raspberry Pi, because there's a gateway. Clearly, maybe it's not industrialized and it's not industrially robust, so that's why there are some other gateways as well. But it was just to say, does it work? And using Cura on such a device, it was working, and you don't have to necessarily, and this is the advantage to have this combination Cura-Capua, you don't have to store, for example, passwords on your local gateway. So this is also, in terms of security, a big advantage. The device is managed by some combinations of MAC addresses and so on, some security hints, and these are managed by the device management application inside Capua. So you have the control over the devices that you're using, and you are also controlling about who is accessing, also as a user, what is allowed to be done here. Eclipse Deep Learning 4J, to be honest, so far we are now currently, this is the fourth pass, the fourth step of the proof of concept that we wanted to go together with the partners, and we are still using this now in our proof of concept. So you can say the proof of concept, the fourth path is not finished. But nevertheless, it's really interesting to see that it's a neural network domain-specific language. If you are familiar with TensorFlow, which is normally used by Python, you have this Deep Learning 4J in terms of Java, because it's Java-based. And you can run it directly for your application if you have, for example, Java runtime environment. And this is, of course, much more robust in terms of application that you're using, because it has many components that you're using for bringing in the artificial intelligence to the edge. And by the way, if you go to the project site in Eclipse of Deep Learning 4J, you can find out that it's part of a software distribution where you find also plenty of other tools which are directly connected to Deep Learning 4J. For example, the n-dimensional 4J, where you transform your data into tensors and into vectors and so on. So also here, I'm not a data scientist. My colleagues would laugh about me if I explain this, but I'm not going to explain machine learning. I just tell you, try even this open source tool for making machine learning directly on your device with Java. Eclipsito, as I mentioned, is a contribution of Bosch, because we are pushing a lot in the direction of the digital twins. As I mentioned, because digital twins are it's a digital representation of your physical devices. And we are going to have, at the end, all of our objects, our things we produce and we realize, and also the things we are handling and interacting directly in a digital space, in a twin space. Why this? Because from this you can start also having new business opportunities. And here is where Mike, for example, intended, even if you start with open source, you still have the power and the possibility to think about new business opportunities. And for us, this is exactly one of these ways we are going to. With Ditto, you have basically also the software. It's a pattern. You can directly define the information how you would like to be stored on your cloud. We are using it on our Bosch cloud. And you have web APIs for interacting. APIs in terms of REST calls or WebSockets, for example, if you have the APIs for Java. And as I mentioned, it decouples the complexity for a programmer to interact with the physical devices. You don't even have to know that there is a physical device. Maybe it's even not a physical device. It's an object which is coming out of a different combination of information sources, and that you realize it as one entity. So you can call it entity, maybe who is more aware about that. And you have a granular authorization control. That means you can define really into the details who, which group, and so on can use it to interact and read data or create data and so on. Eclipse Unide is basically is a protocol. It's a protocol. It's for the performance, a production performance manager. Yeah? This is becoming more and more relevant for many constructor, machine constructor. When it came out, it took really a short time to be a little bit to be more and more diffused between the machine constructors. Not because they are working with us, with Bosch, but it's because they found out that it's really powerful to describe, for example, machine messages, to send measurement messages. How does it work? I hope it's big here. Okay. This is a typical payload. It's a small payload, yeah, where you have, for example, for measurement data, you can see that you are defining which is the endpoint of your device, or which device is sending this data, for example. And the measuring values are represented like this, like time series. Yeah, you have a timestamp, and you say, refer to this timestamp. My temperature and the label itself is the final target, the parameter that I'm labeling. So related to that timestamp, in the time 0, 23, 24, and so on, milliseconds in this case, from that timestamp, I have these three values. So you can, in one shot, send a huge list of time series data directly to your target system, instead of having for each single verbose overhead of payload to be sent for each data to the end system. So it was really interesting for us to see at the end that what we have done in 1 week, or less than 1 week, we met on Monday afternoon. We drew down on picture our IT lens of test how we wanted to do this. And on Thursday afternoon, we saw arriving this coming from the XDK sensor. It was transmitting, maybe you can see it, that are payloads in terms of the values that are measured and transmitted. Of course, it was the first step. We say, okay, the sensor is transmitting to Cura quite easily, to the gateway, and then after different steps and a really interesting teamwork here, because everybody has a part, yeah, of this project, we saw arriving this, for example, also in Tableau. Not directly in Tableau, but as I mentioned in the schema before, it was arriving over the stack to the Kudu, and with Impala, using Tableau, you can access to this data directly. And this was really our, wow, it works. At the same time also, I talked about Performance Manager. The Production Performance Manager applications, we send the data directly with the PPMP, with the protocol. And also here, we start seeing the graphs coming out, so directly, and the messages. And also this was really a breakthrough for us, at least. And yeah, here, just maybe it's, I don't know if this is visible enough. I made a small screenshot. But you see that you can access with Impala to your data as it is a SQL language at the end. You can really use it easily. And this is just one of the examples that we made just for visualizing the digital the digital twins. Maybe it's meaningless for you, but for us it represents, for example, some status of working of the machines that we are using just for our purpose, because now we are extending it also to other business cases. This was the team. This was the project that we, or at least, yeah, the companies working on this proof of concept, and each brought in his own experience, yeah, because you have strong partners, you have a strong solution, okay? It's difficult to have everything in one shot, everything in one hand. So only contributing together in this was the example that we wanted to fetch. So back again, IoT in open source for IoT and industrial IoT, yes, because you can share, you can use open standards, you can have the contribution of a whole community which are interacting. You can contribute yourself, and you can directly, you have less risk implementing that. So you start with open source stack, and then it's up to you, like in the metropolitan station of Tokyo, deciding which way to go. You have the easiest one, you can have also your own preferred direction to use, but this is exactly what I wanted to bring here as my experience, that you can really realize an integration also in industrial environment using open source stack. And yeah, coming to the last slide, what's next? Well, first of all, we have to finish our use case. By the way, it will be presented also on the with the Cloudera, with the cloud on Wednesday, I think. Is it Wednesday afternoon? It will be there is a session where we'll explain, for example, how the visual inspection is done this way, collecting visual so pictures and then analyzed, or at least in the cloud. And yeah, join the Eclipse IoT work group. For me, it was really a pleasure to join, to be here, and to bring my experience, because this is exactly the invitation to everybody to say, contribute with new ideas and components, because building blocks, it's like Lego components, you know. You can bring it together, you shape your own solution as you want, and it makes, of course, sense to share then your experience with the others, like I'm doing today. And yeah, thank you very much. Some questions? In this proof of concept, it was 1, 2, 3, 4, 5, 6 persons, 7. Yeah, but be aware, we started also from an existing IT environment. For example, we had already a virtual machine where we had to just install OpenShift, for example, and there was, for example, a team working on that. But we are 7 people sitting in the same room, but behind us, there were all some organizations of us. Yeah, Red Hat has their own organization behind, so, but yeah, physically 7 people started working on this.
You mentioned security, but do you think that we really have a good handle on the security story for industrial devices and the risks involved?
The devices, security on the devices?
Well, any network-connected industrial devices, there's a risk involved.
It is.
You mentioned that. Do you think we have a good solution for ensuring that that risk is really minimized to the extent it needs to be?
Well, let's say the infrastructure that we are using currently today in Bosch itself, it's quite secure, okay? Because there are some security levels that still makes it secure. What is here in terms of security is not only, or what I mentioned here for security, is not only that we want to protect our corporate environment, but we want to protect also the data that are coming from there. So we don't want, for example, interferences and so on, and we don't want to have ingestions of wrong data, or, for example, give the possibility that devices which are not allowed, they can connect then to a normal environment, just sharing the passwords, for example. If you have, for example, somebody who wants to bring in multiple and multiply, replicate some devices with the same login credentials, well, that's not possible, for example, here in this case. So clearly, we have not found the solution for all, but it was at least interesting to see that this was a solution that works, covering our policies.
Yeah, thank you, Vito, for your talk. I found the part where you said the module is trained on the cloud and then deployed to the edge. I found that kind of fascinating. So, and I guess that's where the Ditto fits in, the abstraction, and the D4, the deep learning, where you learn up there and then you map it to the lower level through those abstractions. Anyway, I find that fascinating. So you find there's support for that? Because up there you have all the data and you can kind of learn on it and then you deploy it, but then you got all the challenges of data formats and encapsulating the device details, but you got to make it all work at there and then deploy it. And maybe you could point me to the right direction and talk more about that. It's fascinating.
Yeah, as I mentioned, this is an ongoing part of the proof of concept. Yeah, at the moment, because we had really less time to think about, go through each and every step. Yeah, but at the end, the idea is exactly, and this is what we are currently fetching. If you have data that, for example, also non-structured data like images, for example. Yeah, I would invite you to visit the booth of Air, or not only the booth, but even the session that we are presenting together with Cloudera, how this is running. how the data can and which accuracy it's possible to train data models in the cloud using the right solutions, and then finding out that these parameters that came out, with different levels of, for example, of networks and so on, that these can be then pushed back with a, I think, PMML. I don't remember now exactly because this is the. By the way, Dave and Jonathan are here, and they are who are doing this work together. I'm just in this case providing data, an environment, and I say, okay, let's use it and let's test it.
So we have time for one or two more questions while Dave, maybe our next speaker, sets up. Yeah.
Hi, Vito. Thank you for this talk. I have a question about Project Vorto. It seems like you're trying to create a repository and model the behavior and the characteristics of the device. Was OCF and IoT something which you had looked at, and did you find that as something which you could have collaborated on rather than?
Excuse me, once again, can you please repeat that?
OCF, the Open Connectivity Foundation, and IoT, which has a similar charter of creating this repository of devices with its characteristics and behavior.
We are running our version of Vorto directly in our Bosch IoT suite. That's why the models the repository is still is there. I don't know now exactly for the OCF. So it's sorry.
I think for Vorto, the idea is that there's lots of models out there. IPSO has models, etc., etc. With Vorto, you have a sort of the common denominator between all those languages or all those ways to describe all the semantics, and you could, I think, pretty easily either import or export OCF like models in Vorto and bring them into the Vorto toolchain. But yeah, I mean, Vito or myself would be happy to introduce you to the Vorto team should you have more questions. One last question.
Hi, good morning. First of all, thanks for the presentation. It was very, I learned a lot seeing that. At one moment, you said that the key to good IoT implementation is having strong partners, a strong solution. So my question was, if you're just a startup or a small company who is just getting started in the IoT development, how can you take advantage of that? If you're not a big company, if you don't have access to Red Hat or things like that, what can you do using the open source capabilities that are today in the world?
Well, again, this is the advantage of using the open source, the Eclipse community, where all these products, all these projects that I have shown here, and at least much more, because it would take a lot of time if I would go more into the details of each of this. And for me, that I'm not really a hard developer, it was also a little bit difficult to find the right words in a summary for this. But at the end, if you go into the Eclipse IoT community in the internet page, you will find, first of all, it's all on GitHub. You can also access to these versions. The support, clearly, since it's open source, you will find the community supporting you. You will find all the questions and so on that you can share. This is the reason why I was also here, because I would like to share with you and say, even in an industrial environment, you can be a big company or a small company. You can use it and it works. Okay. And well, for a startup, I can only recommend that start with using these availability. And behind the community, there are also big players like, for example, Red Hat, Cloudera, and Bosch, and so on. And for them, it's quite bringing in their experience is quite exactly the reason why we are supporting the community.
Thanks very much, Vito.
Thank you.